Your CPU right now is executing billions of instructions per second. Each one follows the same mechanical loop: fetch, decode, execute. What if you could fake that loop entirely in software? What if your code pretended to be a CPU? And I am building one from the scratch in C, starting with one of the most legendary chips ever made, the MOS 6502, the same processor that powered Apple II, the NES, the Commodore 64. Let's get into it. Before we touch a single line of code, you need to understand why the 6502 is the perfect chip to start with. Modern CPUs, x86, ARM, have thousands of instructions, multiple privilege levels, virtual memory, out-of-order execution. If you try to emulate one of those first, you will quit. I promise you. The 6502 has 56 instructions. That's it. It has 6 registers. Its memory model is dead simple. A flat 64 kilobyte of addressable space, no memory management unit, no protected mode, just raw, beautiful simplicity. Before we continue to the next part of our video, if you really like low-level system programming like this, join our newsletter. More than 2000 plus people already joined. The link will be in the description. Let's continue. The 6 registers of 6502 are PC, program counter, points to the next instruction in memory. AC, accumulator, the main register for arithmetic operations. XR and YR, index registers for memory addressing. Status registers, a collection of flags, 0, negative, carry, overflow. SP, stack pointer, that's your entire CPU state. 6 registers, let's model it in C. 1 stack, that's your emulated CPU. The 6502 has a 16-bit address bus. That means it can address 2 to the power of 16 bytes, exactly 65,536 bytes, or 16 kilobytes. In our emulator code, we just allocate that as a plain array. That highlighted region at the very end, 0xFFC and 0xFFD, is special. It's called the reset vector. When a 6502 powers on or resets, it doesn't just start executing from address 0. It reads those 2 bytes, combines them into a 16-bit address and jumps there. That's your program's entry point. This is why when I set up memory for testing, I write it like this: low bytes first, then high byte. Because the 6502 is Little Indian, so 0x00 at 0xFFC and 0x80 at 0xFFD assembles into address 0x8000. That's where my program starts. When you call reset CPU function, here is what has to happen. Read the reset vector, reconstruct the 16-bit address, and point PC at it. That shift and OR operation is just bit manipulation to glue 2 8-bit values into one 16-bit address. Shift the high byte left by 8 positions to make room, then OR in the low byte. Everything a CPU does is a loop forever. Fetch the next byte at PC, decode what instruction that byte means, execute it, increment PC, repeat. In code, this is the CPU step function. First, get the opcode, then identify what opcode needs to be executed. And fetch byte is beautiful in its simplicity. Read whatever byte is at PC. Advanced program counter, return byte, that's it. That's fetch byte. Now let me show you the actual program I am running. I wrote it directly into memory bytes. This is an infinite loop. The CPU jumps to 0x8100, loads the value 0x42 into the accumulator, then jumps back to 0x8000 and does it all over again, forever. Here's my debug output running it for 10 cycles. You can watch the program counter bouncing around. You can see accumulator snap to 0x42 and the moment LDA executes. This is the CPU, laid bare. Right now I have 3 opcodes: NOP, no operations, LDA, load A, load into accumulator immediately, and JMP, jump absolute. The real 6502 has 56 instructions. There are different addressing modes for all of them. Immediate, zero page, absolute, indexed, indirect. Each mode is a different way of computing where the operand lives. The status register flags aren't being set yet. The stack isn't implemented, interrupts aren't implemented, there is no cycle accurate timing. And in the upcoming videos, I will try to implement more parts, and slowly but consistently, I will try to complete the whole CPU emulator. And my end goal is to create a x86 emulator. And if you want to follow along, I have created a Git repository. The link is in the description. Also, if you want to get regular updates, I have a Discord server with more than 1500 people. The link will be in the description. Take care and have a good day.